Now let's talk about another concept called determinant, which can also test the non-singularity of a matrix. So we can use rank to test the non-singularity of a matrix, and we can also use the determinant to do the same thing. So determinant of a matrix is a number that is associated with the matrix, but it can achieve a lot of things. For example, test the non-singularity and to do some other kind of calculation. But here we just talk about the non-singularity, right? So determinant is just a number, right? And only the square matrices have the determinants, right? Only square matrices have determinants. For the non-square matrices like n by n matrix, there's no determinant for that kind of matrix. So only n by n matrix have determinants. And so we use this symbol to represent the determinant of a square matrix A. Right, so this is very similar to the absolute value symbol. Right, we have vertical line here and the matrix, and vertical line here. Right, so this is also called the symbol for the determinant. Right, but it's not the absolute value. Right, they have the different meaning, but they have the same symbol. I see. So if there's a matrix in a two vertical line, so this means the determinant of a matrix, not the absolute value of a matrix, right? So let's talk about how to calculate the determinant of a matrix. So for a 1 by 1 matrix, right? So for example, A is just a A11. It has only one element here, only one element for this 1 by 1 matrix. Then the determinant of A, we can also say that the determinant of A11, the A11 is the matrix, right? In the matrix form. So it's just A11 itself. So for example, if A matrix is number 2, but there's only one number, right? It's number 2. The determinant of A is just a 2, right? And for the 2 by 2 matrix, so for example, A is A11, A12, A21, A22. So the determinant of A is the determinant of this matrix. And we can write the entire matrix in the two vertical lines to represent that this is a determinant of this matrix in the middle. Right? So the determinant of a 2 by 2 matrix is defined to be this equation, A11 times A22 minus A12 times A21. But this is just a definition of the determinant. So for example, if matrix A is 10, 4, 8, and 5, right, so the determinant of A should be 10 times 5 minus 8 times 4, so that's 18. Right, just this diagonal, the multiplication of this diagonal, and the minus the multiplication of the inverse diagonal here. So this is a definition of how to find out the determinant of a very simple matrix, 1 by 1 and 2 by 2 matrix. Okay, so for a higher order matrix, it can be very complicated to find out the determinant. So let's first look at an example of a third order matrix. Okay, so this is a matrix we want to find out determinant of that from A11 to A33. Okay, so the determinant of this matrix, we can also say that the determinant of this matrix is defined to be A11 times the determinant of this little matrix. So pay attention that this little matrix in the middle, so this little matrix A22 A23, A32, A33 is obtained by deleting where the A11 lies. By deleting the rows and the columns where the A11 lies. So for example, A11 here lies in the first row and first column, right? So this little matrix is obtained by deleting the first row and deleting the first column of the original matrix. And what is left is this little matrix here. So we call this subdeterminant. Subdeterminant. So this A22, A23, A32, A33. Right? Okay, once more. The A11 lies in the first row and the first column of the original matrix. And if we delete the first row and the first column of the matrix, what is left, we combine the four numbers left, and this is the little matrix here. Right? Okay, so this is A11. And for the A12, it's similar. Oh, sorry. So A12. So I'll talk about why there's a minus sign here, right? There's a minus sign, there's a positive, there's a plus sign. I will talk about it in a minute. But here, let's first talk about how to find out this little matrix, right? So A12 is the first row and second column element, right, for the original matrix. So this little matrix behind A12 is obtained by deleting the first row and second column, or deleting where the A12 lies for the exact row and column. We delete the row and column where the A12 lies, and what is left is the four elements here, right? And we combine them. So this is the submatrix here, the A12, A23, A31, and A33. And this determinant of this little matrix is called subdeterminant here. It's down here. It's called subdeterminant of A12 or of the matrix A. So this is A12. And for A13, everything is similar. So A13 lies in the first row and third column, right? A13. So this little matrix is obtained by deleting the first row and third column where the A13 lies. And what is left is the four elements here, A21, A21, A22, A31, A32. So these four elements, we combine that together. So this is the submatrix associated with A13. So the determinant of this large matrix A is A11 times the determinant of this 2 by 2 matrix, 2 by 2 submatrix of A11, minus A12 times the determinant of the submatrix here, and plus A13 times the submatrix, the determinant of the matrix here. This is how we calculate the third order determinant. So because we know how to find out the determinant of a 2 by 2 matrix, right? So here, this is just A22 times A33 minus A23 times A32. So this is a definition of a 2 by 2 matrix. Here, there's a definition of how to find out the determinant of a 2 by 2 matrix. And also for the matrix here, the determinant is just the A21, A33 minus A23, A31. So for the last one, it's just A21, A32 minus A22, A31. And so we can rearrange and find this long equation here. So this is the result of a third order determinant. Right, so a little bit complicated. And we'll talk about the we'll talk about some concepts here later on. So this is an example of how to find out the 3 by 3 determinant. Okay, so generally, if we want to find out a higher order determinant, we can use this Laplace expansion, or we call it Laplace expansion. So it is in the example above, this little matrix, right, behind A11 here, or A12 or A13, this 2 by 2 matrix is called the determinant of this little matrix is called a subdeterminant of the determinant of A. And we can obtain this by deleting the first row and first column of A if we are finding the subdeterminant associated with A11. Right? If we want to find out the subdeterminant of A12, then we need to delete the first row, the second column. Right? It depends on which elements we use to find out the subdeterminant. So if we delete the first row and the first column of A, we can get this. So this is called the minor of A11. So it actually has a name, right? From now on, I don't call them the little matrix, right? It actually has a name. It's called minor of A11. So this determinant is called the minor of A11 because this little matrix is associated with A11. Right? If we want to find this, we have to know which A11 and delete the rows and columns where A11 lies. And the results is this little matrix. And it's denoted by N11, the determinant of N11. So N11 for this example is the subdeterminant of A11, or it is a minor of A11. N12 is associated with A12. So it's a subdeterminant of A and it's associated with A12. Right? So this is associated with A13. It's obtained by deleting the first row and third column, and the determinant is called the minor of A13. So this is some concept. Okay. So now let's talk about why here is a minus sign, here is a plus sign. Right, so here we have another concept called cofactor. So cofactor, we use Cij to represent that. Okay. So Cij is closely related to I and j. Right, or I can say the minus sign and the plus sign is associated with the summation of I and j. Right, if the sum of the two subscripts I and j in Nij is even, then Cij is just Nij. Otherwise, Cij is the minus of Nij. So for example here, we know that I think I need to change another color. Okay, I know that this is, oh my god. Let's see. Blue, okay. So we know that this matrix is, this determinant, right, is called M11. Okay. So first, you need to know that the determinant of A, let's find, the determinant of A should be the summation of A, let me write down here. So the determinant of A should be the summation, or A11 times AC11 plus A12 times C12 plus A13 times C13. Right. Everything the same is A11 plus times. So this thing is called C11, right? This is M1. Okay. So here we see that these two equations, this is a definition of the, I don't know why it shows this. This is a definition of how to find out the determinant of A. Right? We use the cofactor C, the determinant of the cofactor C, and times the associated element, and sum this together to find the determinant of A. But here we know that this little matrix or the little determinant is called M11. So this is M12 and M13. The only difference of M and C is that there's a minus sign here and there's a plus sign here. So if change back. So if